it's a weight that's measured, but if it didn't have the name newtons, would there still be force? Yeah. Okay, yeah, so it's a fact. You're giving me a fact about force there, but it's not a characteristic of force. All right, but let's put that over here because I think that's going to be really important. And we're going to put that as a key word. I'm not sure that it fits under the characteristics because this is telling what is force about. I'd like to, how about some of you other folks that have, I'm appreciating all these people that are volunteering, but yes, sir.
Isn't a net force always there?
A net force.
Because it doesn't matter if it's in motion because you got one net force pushing the sphere, so it's always there.
Very good. Good thinking. Yes. There's always a net force, isn't there? Sometimes when there's no motion, what would the net force be? Zero. Very good. But there's still force, isn't there? So there's always a net force. That is something that is always present. Okay. I think we've got those characteristics sorted out. Now, what we have to do is apply it. All right, well, what does this really mean? So now we get to the fun part. Now we get to think about examples. So I'm going to give an example here, and we're going to jot it down here. Here's an example, and you can try this. Let's put this in this example box. Picking up a pen or pencil, just take it, okay, and set it down in front of you. A little experiment here. Take your pen or pencil, just set it down. Now all I want you to do is pick it up to eye level. Okay. Now think about what you just did. Okay. Think about that action of picking it up. And let's run through. Why is that an example of force? And what we're going to do is look here. Was there a net force? How do you know there was a net force? Yes, ma'am. The pencil moved, right? There was nothing holding it back. Now, did it work in pairs? Here we what? We pulled. It's got to work in pairs. So what was the pair force? Gravity. Excellent. Okay, and there probably was a little bit of friction from the molecules in the air, but there's always at least two forces going on. So if you think about picking something up, even though you see that, we don't see the gravity do it, but it's working on it. So it's keeping the pencil down. So very good. What else? Did it act on matter? What was the matter it acted on? Over here, this young lady. Yeah, I know. What was it acting on, though? Did you lift up your pencil?
Yeah.
What was the matter that the force acted on? On the pen, right. It's always acting on something. All right, here's your next example. How many of you play soccer? Or ever played, okay, or kickball? Kicking a ball. Okay, the ball is sitting there, whether it's football, you're going to spike it, or soccer, but you run up to it, give it a kick. There's your example, or non-example. There's your scenario. I want you to think it through. And I also want you to tell me now, not just is it or isn't it, but how did you think it through? I want you to be very aware of how you're thinking. Because if you know how to think about things, you're going to be able to apply it a long time after. So we're not only just working on this concept of force, we're also learning how to think it through. So I want you to be able to tell me that, okay? All right, go for it. You got about 2 minutes.
Okay. Sort of like transferring the force, like movement to like and like. So do we have a force acting against it? You gave it a push with your foot. Is there anything?
It depends. If you kick it hard enough, it goes in the air. Then there's nothing really. But if it's on the ground, it's gravity.
Okay, on the ground there would be friction. What about in the air? Just like kind of falling down. Like it would like go up and then like what makes it come back down? Is there anything in the air that could interact with it that could push against it? Okay, so there could be some air molecules pushing against it in the air. On the ground, you think the ground could act against it, and then if it's in the air, gravity. There's a lot of forces involved here, is it true? Okay. And what is the matter with that? Keep it off.
Everyone make a decision? All right. How many of you think it was an example of force, is the way we've described and talked about it? Okay, you guys thought so this time? Did anybody not think it was an example? Okay, everybody thought it was. Yeah, it's definitely an example, isn't it? Applying force to a ball, right? It moves. So here's the more important question, all right? I mean, or just as important question. How did you make that decision? How did you know? This young lady back here.
Because it's just like the bike thing. It starts out like not moving at all until you have to like push it or something, and it's just like kicking the ball, and then it'll eventually stop if you like.
It is, isn't it? But how did you go about? Did you check it against anything here? And how do you know, or did you just intuitively know that was a force?
I just intuitively.
Okay, and this is where we want to get, because there's certain things that we know intuitively, but as we go up in the grades and things get harder and harder, I want you to have a process for understanding how do I go about this. I think you know, but this young lady here.
Okay. We kind of, like, we went through and we checked, so we said since it's moving, it would be an unbalanced force since it was moving, and since it's moving, there's a net force to it.
Good.
And we kind of just went through the lesson, we checked it off, and there's like, oh, so there's more, like, there's really nothing in the never present, so there's some present and always present, so we just kind of figured it was a...
Does it have all of the always present? Did you go through each one? Good. Something you want to add?
It has the net force because it's in motion. The pairs would be friction because of the air. There's that water friction, and then there's the gravity pulling on it,
Okay.
and then there's the third one pulling on it, and then what's acting on it would be gravity. It's pulling it back down to the earth, and then the friction stops it.
And then there's that initial just push of on the ball too with the kick, right? It's an instantaneous. Good. We talked about that too, didn't we, Dylan? That it's not a constant force. It's an instant force that we put on the ball and it moves. What the process is when you think about a concept is you have to check through. And I asked Dylan, this was my question to him. I said, Dylan, if you got this as an essay question on a test, so you had to write a short answer, and he went right through it. And I said, man, you nabbed that one. That was very good. Because the idea for doing this, checking the example against each one of these always present characteristics.